Okay, my name is Mark Gray. I'm Vice President of Engineering Operations at Nimbis Services. Nimbis builds cloud service portals for high-performance computing resources. And we currently have 5 different cloud portal service programs, and specifically in this, what I'm sharing here is our case study in our cloud services for Mathematica portal. So the outline. First, a brief introduction on our company, and then have some slides on our Nimbis Cloud Portal, and it's the overall infrastructure that we've developed for hosting these different portal programs. And then the rest of it's all focused on the cloud services for Mathematica. I'll share some results and conclusions from our case study, and then I'll open up for questions. We don't have too long. Some of these I might go through pretty fast. I had a hard time trimming this down. First, about Nimbis, we partner with cycle providers, high-performance computing cycle providers, independent software vendors, and domain experts to bring together these HPC cloud portals. Services that otherwise wouldn't be available. Our target market is experimental and periodic desktop users that ordinarily do not have access to HPC. So we're trying to make it more accessible, more affordable, easy to get to. So how do we fit into this? So at the top here, I show you different kind of desktop users: researchers, scientists, analysts, engineers. And down here we have our HPC data centers. In this particular one, in this particular case study, the 2 data centers that we're looking at is our systems and Amazon services, Amazon's web service EC2. The software that we're looking at is, of course, Mathematica. So we are in the middle here and kind of shown in the cloud, and the idea is to make the service easy to use, easy to get to through a cloud portal for people on the desktop. And this is kind of a view inside now. Inside our portal we have these 2 subsystems. We have an e-commerce front end, which we developed using open source software, Drupal as a content management system and content framework, and UberCart for the e-commerce aspects of the portal. So within that environment of Drupal and UberCart, which is open source, we tailored it for HPC on-demand services. Okay, if you go to our home page, this is our visitors homepage. These are the 5 different programs that we have under development. We have more coming soon. And if you go to our homepage, you can register for our cloud services for Mathematica Beta 2. We just recently ended our Beta 1 program, which ends this case study, and I'll show you the feedback we got from that. We are now looking for Beta 2 users, and so we'd really appreciate if you come to our site, sign up, and check it out. So if you go to the home page, the first part of a process in any of our portal programs, you have to register for it. So you go to our home page, you click on this register, comes up with a registration form, fill it out, and within 24 hours, we'll review it and email you back with authentication. You'll get your username and password. And when you log in, the home page, for every different portal program, it gives you different access rights to different areas of our website for the different programs that we have, and each one has its own home page. So when you log into to the Cloud Mathematica, or the Cloud Services for Mathematica, you see this home page here, which gives you a step-by-step instructions on how to use the site for this particular service. Just Cloud Services for Mathematica. So this is a blow-up of that page. Step 1, generating a quote. Again, I'm showing the e-commerce aspects of this study as well as the performance aspects. So for the e-commerce part, there's quote generation. You may need to generate a purchase order for your buyer in order to purchase our services. So you can go through and generate a quote. Buying Nimbis points. The concept there is that if you have a large project and you know you've experimented with the service, you know you're going to be using it, you can buy a block of Nimbis points and partition the points up. Every time you run a job or order something online, instead of paying by credit card every time or a purchase order, you use Nimbis points. It makes the ordering of a job much simpler. What I'm going to focus on here is actually step 3, ordering and running a job. So once you've logged in, you go to our catalog, and right now we have 2 listings, the Mathematica on Amazon EC2 and on our systems. So if you click on that, it brings up a page and it shows you the different Amazon instances that we have pre-configured. So one of the things that Nimbis has done for the users already is we've created these pre-configured instances that will run Mathematica on these particular Amazon instances. And so when you order one of these, I'll step through the process. At some point lower on, you attach your notebook and upload it to the cloud. So we're going to look at a standard small for this. And so this is, each one has its own product page showing you what the configuration is. At the bottom of the catalog page is where you actually choose your job options. So in this spot, you select how many kernels in this one. Actually, I found out today that the job that we're running was written by Stephen Wolfram a long time ago. We asked him give us a job that we can run, and it was a little program you see at the end that shows a cube in different variations. I just found out today what I've been running all along, Stephen wrote. So this one runs on 2 kernels, 2 instances. You can give it a timeout limit. It actually runs in 2 minutes, but this is in hours. Add to cart. When you add to cart, it pops up your shopping cart, and in there is where you select to upload your notebook. So you click on it, you go, this is locally on your machine, and you select your notebook file that you've written, and then when you hit checkout and go to checkout, so at this point it's loaded into your user account on our portal. It's not yet on the cloud. You have to finish the payment process. You go through and you pay, you go through your agreement, hit review order. So what I'm showing you here, we're going through all this process and we've made it really easy and tailored. So all you do is submit a notebook. You have to have a Mathematica desktop license. That's the requirement. The licensing inside the cloud is on us, and it's part of the pricing that we provide to you. So your only requirement is a desktop Mathematica license, and we go to production. You not only have to have the desktop Mathematica, but have added the Premier service. So if you have Premier service Mathematica, you can use production version. So you go to, you click on that. So let me back up. When you submit the order, here's where the payment happens, and this is where your notebook now goes from your user account area on our portal website down into the cloud. And then it pops up a screen, a job view screen, that shows that the job is executing. It shows you what version of Mathematica it is. It's a 7 32-bit instance. Describes the platform, tells you what your notebook is. And this waiting for the job to finish. When the job finishes, all the results, any output notebook that's been generated, any files that have been generated externally to your notebook will show up in this window. And you can download them then, move them back from the cloud into your user account. And they stay there in your user account. You can come back and look at My Jobs and see all jobs that you've ran in the past and upload the results from there. So when the job finishes, it tells you your execution time. In this case, it was 2 minutes. And here's the output notebook file. If you click on this, it will download, or not download, but upload. Well, I guess it's all relative. Yeah, in this case, it's downloading, right? So we're getting this output file. And when it's done and you click open, I have Mathematica installed. If you have Mathematica installed in your laptop, it automatically opens it up and shows you the results. So this next page shows you the results. So all of that just ran in the cloud, was uploaded back onto your laptop. So you can create notebooks. And what's running down in our cloud is actually Grid Mathematica. And so when you write your notebooks, you have to, if you want to parallelize them, you have to use parallel instructions. And If you do interactive input, this is, if you notice, this was a batch submission. It was not an interactive submission where you ran Mathematica. So it's running batch in the cloud, and you get the results. So there's no interaction that you can see here. However, that was beta 1. In beta 2, we're adding, we're working on it. Some of the feedback we got from the users I'll show you. So here's a summary. We went through and all the way from browsing, selecting a provider, configuring options, submitting the job, all the way to displaying the output. And so I've been using this word job. What's job? It's your notebook plus the compute resource. In this case, we ran it on Amazon EC2 plus a Mathematica plus time. That's a job. And so this is a job-oriented, single notebook batch submission that you've seen. Okay, so the results and conclusion. I have a picture here that shows the configuration on Amazon, and then I have a picture on our systems, and then I show you the results and a comparison running on the two. Our systems is a physical environment, and Amazon is a virtual environment. So what you need, so here's the user requirements. Basically, you need this is for Mathematica 7. We're going to go to 8 when it's available. You need a web browser, internet connection, and your input notebook and data files. Nimbis appears in the cloud to you. It's our website. You get an account on it. There's a catalog, and then you have your user account where your notebooks are stored. Okay, down in this area, this is the high-performance computing resource that we're providing the portal to. We have an SSH tunnel from our back end. We actually have written in here, like I mentioned Drupal, we've written a module that plugs into Drupal and an UberCart e-commerce front end that talks to, that uses this SSH tunnel to configure and launch the instances of your notebook. And so down here, we do all the license management, and we have Grid Mathematica running. And these are the different Amazon different services that they have right now. I showed you an EC2 small in this one, and the benchmark that I'm going to show you was done on this high-end one, which is a high mem quad extra large. So how does this compare to the R system? So the R systems is very similar, no difference in the user requirements, no difference here. The difference is basically that you now have dedicated hardware resources, and they have two types of nodes, a Woodcrest and a Cloverton. And we have our own physical node that we have installed right there on site at our systems. So really not too much difference in the configurations of the two. Real differences are really in the fact that this is a virtual environment and this is a hardware, bare hardware type environment. So we had this test notebook that ran a bunch of FFTs, and this is just relative results we're showing here. So so the virtual environment was this Amazon, and they do disclose what they're using physically underneath, although it's being shared and it's a virtual environment, that it's a 4-core Intel Xeon. It's a new Nihilum processor. And we're comparing it to our systems, which is also a 4-core Intel, but it's not the latest Nihilum. It's I forget specifically what model number it is, but similar speed, but this does hyper-threading and a lot of neat stuff. So we're comparing a virtual environment on that and this on a physical. We actually get a 15% performance increase running it down here, and this isn't even as capable as a processor up there. In addition, it's 30% lower cost. This is a good environment for experimenting. You could use the small instances or the low-end stuff to just functionally see that things work. It's a good way to use this. And then when you really want to deploy and do your processing, you should consider more of a the hardware type environment, physical environment. So those are the performance results. This is a listing of observations and conclusions based on all the feedback we got from our Beta 1 users. And a lot of this revolves around the fact that most desktop Mathematica users aren't used to, and obviously, using batch submission to an HPC resource. So there wasn't a lot of visibility into what it's doing. And a lot of this feedback is based on that. Like the first one, our conclusion is, remote West-based notebook submission lacks sufficient interaction. Things would hang up, there'd be bugs, and they wouldn't know what's going on. And we'd have to go in from the back end and see what was going on. Sometimes their programs would crash or have bugs, and there'd be like, okay, who pays for this hour that I paid for? Was it our service, or was it their notebook that had a bug in it? That kind of thing. So we needed to really decouple the operation and results of the notebook from actual payment of the service. Instead of paying per notebook idea, just they buy a whole block of time and run as many notebooks, and they can have successes or failures, but it's not actually tied to the payment. Another conclusion was that the shopping cart notebook process is cumbersome. There's a lot of steps that you see that you have to go through every time you submit a job. We'd like to make that easier. You just, again, buy a block of time. And what I said already, most Mathematica users appear to be interactive. So in Beta 2, which is starting November 1st, and again, as I said in the beginning, we're looking for Beta 2 users. We have additional functionality that we're adding, and one is the visual aspect, the big thing that you can't see what it's doing. So on the job view window, we're adding a VNC, which is the virtual networking computer technology for remote desktop. So what we actually will have here now on the Beta 2 that starts in November is when you put the notebook down there, you can choose to look at how it's operating. You can actually see it. If it pops up and saying I'm waiting on an input, or the front end part of Mathematica says there's a problem or whatever, you can see it. It'll be right there in a VNC window. So you'll know what's going on. And the other thing is, right now we had the ability just to upload a notebook. And the notebook either had to contain the data or generate the data, but we have multiple data file uploads now capability in the Beta 2. Also, we've added process monitoring and retries on errors, just making the whole system robust, and this is related to that also. Error filtering and trying to identify the cause of the error. Future enhancements that we're looking beyond Beta 2. There's two different kind of models here that we'd like to explore. We need to talk more with Wolfram Research about this, but the use of one is buying private Mathematica clouds. Instead of buying and running a job, you buy a cloud, a Mathematica cloud, and it's not a per job notebook. The other is, and in that case, you still have the requirement to have a license, but things run entirely in the cloud. The other is a private Mathematica compute kernel cloud, in which case it's using lightweight grid manager, and the master node running on your machine in its visual interface is actually running on your machine, and the rest of it is running using lightweight grid manager in the cloud. So those are future enhancements that are under consideration. So our conclusion was that we feel that Beta 1 was very successful. We learned a lot, and our customers, or our Beta users, I don't know, I think they pretty much enjoyed using it, and they're looking forward to being Beta 2 users. So not only will we have that base, but we'd like to get some more users. So it was very successful. We had a big diversity of application developers, and some are quantum mechanics and particle physics, and I think there's some chemistry and biology and lots of different application areas. So we found out what works, what doesn't work, and how we can improve things. Beta 2 launch is November 1st. New capabilities are being introduced, as I pointed out, and we're looking for Beta 2 users. Production release, we're targeting January 2011. And at that point, right now as a Beta 2 user, one of the things that you can leverage off from is the fact that you don't have to have the Premier service. The only requirement right now is a desktop Mathematica license. But when we go to production, that'll change to that. And we have greater pricing right now, too, so when we go to production, pricing might change a little. Here's a nice quote that one of the execs from Wolfram gave about our service. All right. Well, thank you, everybody.